So hello everyone, today I am going to talk about a bandwidth optimization architecture. In a simple word, a bandwidth means how much data can travel through a network at a time. When many users devices use the network bandwidth can get overloaded. So bandwidth optimization uh, architecture is a smart way of designing a network so that data move faster, less network consistency happens, and performance improve. This is very important area like a cloud computing, streaming, and a large scale application. So in the next slide, data compression. This slide show data compression. Here is a large data is reduced into a smaller size before sending it over the network. This helps save bandwidth to improve speed. There are two main types: lossless compression and a lossy compression. In a lossy compression, some data is lost. In a lossless compression, data loss is a zero. As we can in a diagram, raw data is a compressed before a transmission. Raw data is compressed before a transmission. This reduces the load and increase the efficiency. So overall compression helps faster data transfer, lower bandwidth usage, better performance. And interact with third slide. So in our third slide, edge catching is a viewing. This slide explaining edge catching. In this method, data is stored closer to user instead of a central server. For example, frequently used data is saved in a nearby location. So when a user requests data, it is delivered quickly. Network traffic is reduced. As shown in the diagram, data is distributed across multiple nodes. In this approach, edge coaching benefits are faster response time, redundancy latency, and less load on a main server. This is commonly used in CDNs like videos streaming platforms. And our fourth slide interact with fourth slide. So in a fourth slide, QoS flow, quality of a service. This slide shows QoS flows, which means quality of a service. Here, network traffic is managed based on a priority. Importance data is given higher priority than a lesser importance data. So, for example, video calls and a live streaming a high priority, downloads lower priority. In this diagram, different types of a traffic area handled separately. In this first slide, QoS flow, quality of a service, uh, benefits smooth performance for important tasks, better user experience, and efficient bandwidth. In a given diagram, so less data is reduced and a lower priority downloads and etc. So in conclusion, the bandwidth optimization architecture help improve network performance by reducing data size, bring data closer to user, prioritize important traffics. This technique makes the network faster, smarter, and more efficient. Thank you.